So we're getting down to basics here. I have my puppy next door right here, and I hope she's good throughout this training. What is a PV system really? This is Solar 101 for non-technical professionals and everybody else. So here's the things that we have to think about. When we talk about solar, or if you're working in the profession, you say, I work in the solar, the only thing people think about are the solar modules or the panels. Oh, I've seen those panels, but they don't understand it's an ecosystem. And that ecosystem is what gives us our total working power. So, first of all, let's understand what PV stands for. What most people don't realize that we just call it PV, just like we call it Google, when it's actually we want to search for something. PV stands for photovoltaic. PV is derived from photo, which is light, and voltaic, which is electricity. Therefore, a PV system is designed to generate electricity directly from light. What are the four components? And this is important to understand if you're a non-technical person, because you may work in one of these succinct industries and not know how they connect. So PV panels or PV modules, they capture sunlight and convert it into direct current DC electricity like they do with batteries. So if you have an A cell battery or a D cell battery or something like that, then that's what it produces, not AC. AC is from your home. That's what the inverter is for. The inverter converts the DC energy from the panels into alternating current or AC electricity usable by homes and appliances for the grid and the grid, because you can push energy onto the grid to help support it. Now, how do you keep your modules on a roof or on a pergola or on the ground? Well, you use what is called racking and mounting systems. These securely attach PV modules to the roof or ground, ensuring optimal sun exposure and stability. Because racking is not just some wood that's put up, it has to be tested for snow load, wind load, so the modules literally don't fly off. Then you have your electrical connections to your home. This integrates the system with the home's electrical panel for power usage, for storage, and for grid. And in today's market, we've added one more component, actually two, which is the battery system, or BESS. BESS has been a game changer in our industry. So the components of a panel system, the components of a solar power system is our PV panels. They capture the sunlight, the inverter, transform the DC into AC, the racking and mounting system, which securely attaches the modules to your roof or ground, and the electrical components, which you see here. These safely integrate the solar power into your home's electrical system and to the utility grid, so it can be done so safely so it doesn't cause any harm. Now, the inverter, it's bringing the solar power, it's bridging the solar power to your home. The electrical currency converter, solar panels generate DC. Home's language, your household appliances and grid operate on alternating current, so they can't do anything with this DC. The inverter's essential function is to efficiently, hear that word, efficiently convert DC power from your home solar panels into usable AC power that your home can use immediately. So this is how it works. You have your solar panels on the roof. You have it wired down to the inverter converts that DC to AC. The AC goes into your home. So if your washing machine is going, your television is running, you have your lights on, it'll use that energy from the PV first, from your PV and your inverter, from your modules and your inverter, use that first. Then, if your PV system is producing more energy than you're using, what's going to happen? It's going to send it to the grid. That was historically how it worked. But then, somewhere around the mid-teens, into 2020, batteries became more prevalent. So systems start getting upsized. So now I'm going to send energy to your home. I'm going to send energy to your battery. Anything above those two, I'm going to send out to the grid. It's that simple. Enabling solar energy without the inverter, the power generated by solar panels would not be compatible with your home's electricity system or the utility grid. Basically, it'd just be a big daytime battery that you could hook DC power to. And unless you have DC appliances, it's null and void. So string inverters, were string inverters a single inverter for a string of modules or panels. And this is the most cost-effective, simple roof layouts, systems that are historically the norm. But then somewhere around 2008 to 2010, we started coming out with microinverters and power optimizers. Microinverters are actually small inverters that you put on each solar module or solar panel, and then it's converted right there at the panel, and then all those are added together and then shipped into your home. So you have basically these little power plants that go behind the module. Then you have power optimizers. Remember that thing called shading? This is where microinverters and power optimizers help out a lot. Power optimizers, what they do is they're paired with a central inverter. And what they do is they optimize each panel's output so you don't get that effect where stepping on the garden hose. You can still produce as much power as those unaffected modules can. So if you have one that's shaded, you have optimizers on it, the others aren't affected. That's how that works. So connected to the utility grid, a critical component of most PV systems is the connection to the utility grid. This is where you have to get approval from your AHJ or your utility. This connection serves as a dual purpose, exporting excess power when your solar modules are generating more electricity than your home can use and is more than I'm getting tongue-tied here. When your solar panel generates more electricity than your home or business is currently consuming, the excess power is sent back to the utility. This often compensates through mechanisms like net metering, where you get credits on your electricity bill for the power you supply to the utility. Now, importing power when needed, conversely, like I said, those cloudy days, if you just had an off-grid system and you were totally off-grid on cloudy days, you may need a generator or something like that. Conversely, when your solar panels are not producing enough power to meet your demands, such as during the night or on heavily overcast days, or during periods of high energy use, your system draws electricity from the grid. It's basically your backup if you have a really good designed PV system or really well-designed PV system. This integration allows you for efficient energy management and to like lower your carbon footprint as well. So there's two types of systems that we've kind of been seeing, but there's actually three. There's the grid tie system where if the grid goes down, that inverter goes down. There's no power. I don't care how much sun you have. If the grid goes down, it's a wrap. It's a done deal. So this was historically the most common type that you saw in California and Arizona as of maybe 10 years ago. But then you have off-grid systems, which are independent. So when the pandemic happened, a lot of people started getting into off-grid systems because they were doing that van life thing and they were just going off-grid. These systems are independent systems and are not connected to the grid. They do their own thing. Now, when you add a battery to it, you have to get a different type of inverter. A battery storage system functions as backup power or arbitraging your rates to make them lower, and it captures excess solar energy generated during the day and stores it so it can be used at night during power outages or to manage electricity costs by utilizing stored energy during peak hours. Rate arbitrage. For this, you need a hybrid string inverter or a hybrid microinverter so that it knows what to do with that excess energy. So the residential solar, you got PV modules or PV panels, you have your racking, you have your inverter, you have your electrical panel, you have your smart utility meter. It measures the flow of energy to and from, and you have your grid connection, which connects into the grid. So your excess power you can send to the grid so that you can make credits or get paid for it. This is really important. Our key takeaways here: panels capture solar energy, inverters convert the energy from DC to AC, racking securely mounts the modules and keeps them safe from wind and snow from collapsing in or blowing away, and electrical connections. This is putting it all together and bringing the energy into your home so that you can have, ta-da, a PV system. So, in reflection, let's identify PV system components. Which part of the photovoltaic system do you find most challenging to explain clearly? Articulating your reasoning. What is it about the specific components that make you feel less confident? Consider its functions, technical detail, and complexity. So you know this is a chain. We have panels, racking, inverter. We have our electrical connection into the home, and we have our meter. It's a flow. So think down to from the roof. We got to go through into the utility. If you have any questions, you can always reach out to me on LinkedIn. It's Emmett Muckles. There's not too many of me. Remember, find me. Till next time. Peace.